Okay, folks, I was on number 22 and I talked myself into a mess. I had to stop and get this in my own mind before I try to explain it to you. So I'm going to tell you that if you are even remotely confused about permutations, I would skip this problem. This is really an algebra problem. It's very much a theory problem, and it's incredibly difficult to explain, I think, and to understand. But I am not going to skip it. I'm going to go ahead for those of you who want to see it. But again, please feel free just to skip this video. That's why I'm putting it on a film by itself. So you can just skip over it if you don't want to see it. All right, I'm looking at number 22. There are 380 ways the Springfield Begonia Society can elect a chairperson and a treasurer from among their members. How many members are in the society? Well, this is a permutation because we have a number of members and we have two positions that we want to elect from this society. So the permutation, the number of combinations, is based on the number of members, which we don't know, but we know that there are two positions up for grabs. There's the chairperson and the treasurer. And that those permutations, those different combinations of members are equal to 380 possible combinations. So this time, instead of finding the permutations, we know the permutations. And that's what makes this an algebra problem. We're looking for the value of n. So we're going to have to substitute the actual formula for permutation, and that's right here, instead of that Pn2 value. So this becomes the formula that I'm going to solve. This formula equals this value for permutations. So I'm going to bring that over here, or actually I think I'll bring it down here, where we have, no, I'm going to bring it up here. We have n factorial over n minus k, and remember we know k in this situation. We have treasurer and chairperson, and that is going to equal the 380. Okay? So now we have to really expand our formula. We're going to have to break down what n factorial literally means. Now remember, if we have like 5 factorial, and I'm just picking 5 as an example, we did 5 times 4 times 3 times 2 times 1 to get the factorial. Each of these numbers is 1 less than the number in front of it. And the same is true here. N factorial is just going to be n times n minus 1, 1 less, times n minus 2, and so on. It could go on as long as you needed it to. That's what n factorial literally means. So instead of n factorial, I'm going to use that. I'm going to say n times n minus 1 times n minus 2, and so on. I could go on as long as I needed to, but this is as far as I have to go because we have n minus 2 factorial starts with n minus 2, and that's all I need because that's what I'm trying to cancel right here. So here is sort of a stretched out version of that first formula. Normally with these problems, we're trying to simplify this. But in this situation, we're stretching it out. We're expanding it. And here's why. Because once I expand it, look at what I can do. I can cancel that bottom term away. So that simplifies to n times n minus 1. And I think I'm going to go ahead and leave it in this form because I want to show you something here. N minus 1 is 380. Okay. So we need to figure out what the value of n is going to be. Notice that k is no longer a part of this equation because we substituted in that 2. K got sort of absorbed into the equation. So what you would have to realize here is that these are factors of 380 because they're being multiplied to get 380. So I'm going to set up a table just to help us organize this of factors of 380. So what are some ways that I could make 380 using multiplication? Well, using my calculator, I know that I could say 380 times 1. That would work. 190 times 2 would work. 380 divided by 3 is not even. 380 divided by 4 is 95. So 95 times 4. 380 divided by 5 would be 76 times 5. 380 divided by 6 will not go. 380 divided by 7 will not go. 380 divided by 8 will not go. 380 divided by 9 will not go. 380 divided by 10 will work because that's going to be 38 by 10. 380 times, 380 divided by 11 will not work. 380 divided by 12 will not work. 380 divided by 13, nope. 380 divided by 14, nope. 380 divided by 16, nope. 380 divided by 17, nope. 380 divided by 18, nope. 380 divided by 19, yes. And this is where I stop. And the way that I know that I stop is because the next one would just reverse this one. 380 divided by 20 is 19. Let me draw that for you. Gosh, this problem is a monster. Let me put one more row right down here. Whoa. Can you tell I need to eat? It's almost 11 o'clock at night, and I haven't done. Okay, so the next one would be 380 divided by 20 is 19. So this would turn that same one around, and then we just start back down the line. So that tells me we've reached the end there. But those are the two that I want. Because look at this. N times n minus 1 is 380. If n is 20, what's 20 minus 1? 19. And that is 380. That checks out to be true. And what is n? Right there it is. N is 20. This is probably the hardest problem I've seen in this book. This may be the hardest problem I've seen in my adult ed career. This is a tough one. It is very much an algebra-based problem, but you have to factor the 380 to figure out which one of them fits. So to answer this question, I'm going to pick C as in Charlie, and I'm not even going to wait to check this one. I'm not going to wait till the end of the page. I'm going to go back to page 34 and hope and pray that I got this one right. So while I'm here, let me just check what I've got. This is on page 34. We're starting with number 16. All right. Number 16 is E as in echo. Number 17, A as in alpha. 18, B as in Bravo. 19 is C as in Charlie. 20 is D as in Delta. 21 is B as in Bravo. And then here comes the beast. Number 22 is C as in Charlie. And I am going to stop this video so that if you skipped this video, you won't be lost on the next one. So I'll see you in the next video for number 23.